right, so this is the unit review for scatter plots and linear regression. We're going to be making a lot of scatter plots here. It's going to be a little bit easier for you to do this one, especially on your own, and kind of double check your interpretation with me, because the scatter plot is going to be a little hard to count on my screen as well as yours. Number one says, as the number of farms have decreased in the United States, the size of the remaining farms has grown larger. The table below shows the average acres per farm in the United States starting in 1900. And so what we're thinking here is we don't have a year zero, but year zero would be 1900. And so on our graph, we don't have 1910, we have 10. So I think that's something that's what you would plot at 10. We're going to plot 139, 20, 30, 40, 50, and this is going to be 59, 69, 78, 87, and 97. Of course, we're going to have to estimate a little bit, and that's not a big deal. Just make sure you're kind of getting in between your numbers there. So at 10, we're going to go up 139, and I know my grid is small here, and I'll just flip so I have one page so you can see it a little better. Because you have that data in front of you. So at 10, we're going to go up to 139. So it's just going to be below 140. Our next data point is 20. We're going to go up to 149. So it's going to be pretty much right between 140 and 160. At 30, we're going to go up to 157, so just below 160. At 40, we're going to go up to 175. So in the middle there of 180 and 160. At 50, we're going to go over to 216. And what I did when I was doing this on my paper is to make sure I got every one of these data points, as I was going, I marked them off. So we are there. We got to 150, I believe. At 59, we're going to go up to 303. So just on this side of 60, all the way up just past 300. At 169, we're going to be at 390. 380, 390 would be about in here. Just double checking where I am. And that was at 69, 78. So between 75 and 80, we're going to go up to 449. So right in the middle there. And then at 87, so right between 85 and 90, we're going to go up to 462. So just on this side of that line. And then at 197, we're going to go to 487. So right between 95 and 100, 487 would be somewhere in there. So, scatter plot. Our axis, actually, it says let X represent the number of years since 1990. So years since 1990, or sorry, 1900, not 1990. And then our y-axis is average acres. Okay. So make a scatter plot, label both axes. Done. Sketch a line of best fit on your scatter plot. Okay, so sketch a line of best fit. Here you can use any straight edge you have, and try to make sure that you have the same number of dots below your straight edge as you have above. So I'm going to start down here. I'm just going to play with it a little bit. This is what you can do with the straight edge. Right now I have 1, 2, 3, 4, 5 above and 3 below. So I think I needed a little more slopey. 1, 2, 3, 4, 5 above, 1, 2, 3, 4, 5 below. That's pretty good. I'm going to drop that there. So our best fit line gives us that trend of our data, and it lets us make, draw some conclusions. So there's our line of best fit. That line doesn't have to be perfect. Your line can be a little different than mine. You might not need to have the exact same y-intercept or the same slope, and that's absolutely fine, as long as you have the same number of dots below and above your scatter plot. On your scatter plot. The other thing that's really important here is the best fit line is not connect the dots, right? It's a line that we can kind of, we use it to average out our data. Okay, use the line that we built, that we drew in Part B to estimate the average number of acres of a farm in 1955. So 55 is here. We don't have a dot on that line, so that's why we're going to, we don't have a dot, we don't have a data point, so that's why we're going to use our best fit line. So I'm going to go up here, that's where my line is, and it's at 300. So it might be a little below 300, I'm going to say 300 acres. And now we're going to use Desmos to find the exact line of best fit. So select Desmos and add your table to put the data in. I'm going to do the same. Well, I'm going to pause while I do those so you don't have to watch me enter all of that. So again, anytime we're doing statistics, we're adding a table to work from. And what you're going to put in here, since our x-axis is in like 10, 20, 30, 40, that's what we're going to be entering, not 1910, 1920. So I'm going to start entering that data. It's going to look like this as I do it. And I will let you do the same, and we'll meet up once that data is in your scatter plot. Okay, so there is my data in the scatter plot. That is 10 data points, and to double check my work, that's the first thing I do to check. I make sure that I have those 10 data points there that match. It's really important to make sure you have the data in right so that you can get the correct equation. So now we're going to put that equation in. So to get the equation of the best fit line, the really, really good one, we're going to do y1, because we wanted to look back at that table we built. And then we have to do the little tilde guy. And it's the guy that's right above your tab button on your keyboard. You need that little guy. And then we do mx1. Oh, and it's there below your B as well on your keyboard. mx1 plus, and then B, we want a line, and so that's what we're asking for. What this gives us is a lot of really good information. Not only do we get the slope and the y-intercept as M and B, but we also get our R value. So if I was working this problem on a test, definitely I would not touch that screen and not do anything with that, not make that screen go away or clear it out until I'd used all of those. So use Desmos to find the exact line of best fit. So our exact line of best fit here we have y equals mx plus b, and our m here was 4.717. I don't know what that just did. 4.7 is what I would do. Oh, it says 2 decimal places, so 4.72, rounding correctly there. And then our b is 37.93. Awesome. And then our R value comes from that little screen as well. Our R value is right there. We We don't want the R squared, we want the R value. And there it's 0.9647. And now Desmos has done everything that it can for us, and the only work we have to do is interpret. What does this R value tell us about the strength of our model? Well, that R value is really close to 1, so it tells us our model is a really good model. Our R value is really close to 1, so it is strong, and it is positive. Remember, this is a correlation. The years are not causing this to happen. As the years increase, the acres per farm are increasing, but that's not happening just because the years are happening. It's because other things are happening in the economic system over this time. All right, interpret the slope of our model in context. So when we were doing this in our linear modeling unit, we did a lot of writing y over x, and that's what I'm going to start with here. And if we look back at our y-axis, it was average acres. And our x-axis was years. So our slope was 4.718, so we would say 4.72, and it's positive, so the average acres per farm is increasing by 4.72 acres per year. If you have that written, I think on the OST, you will be able to match that to a description. All right, interpret the y-intercept. All right, our y-intercept was 37.93. So what we would say here is in 1900, that's our year 0. The average acres Use your model to predict the average number of acres on a farm in 1955. Okay, so now we need to do work with our model that we found on Desmos, not the line that we wrote. So what we need to do is put 55 into our equation that we got out of Desmos. So we would do something like this. If you could use Desmos, oops, I'm sorry, that's 37, not 39. I got 9 happy there. And then you would just put this, put that in the calculator, and you get 297.42. Which is really close to 300. So the model that we wrote, or that we drew, was really close to the model that we found on Desmos. All right, I'll make another video for number 2. So go ahead and finish up this problem and come back to get help with number 2 if you need it.